Today I want to show how to sketch the graph of logarithmic functions and to determine their domains. Let's look at the first one, f of x. The parent function of this logarithmic function is log of x with base 2. Here is what the graph looks like. It has the y-axis as the vertical asymptote, 1, 0 being the x-intercept, and it is an increasing curve. Going forward, we'll keep track of these important features after each elementary step. First, we're going to shape the graph, the parent function, left by 1 unit. That's going to give us a graph for y equals log of x plus 1 with base 2. Still is going to be an increasing curve, but 1, 0 from the parent function moved leftward to 0, 0, which is origin. And the vertical asymptote shifted to x equals -1. Next, we're going to reflect the graph this function across the x-axis. That's going to give us y equals negative of log of x plus 1 with base 2. Still, x equals -1 is the vertical asymptote. Origin is the x-intercept. But all other points will get reflected across the x-axis. So that's why we have this decreasing curve here. But still, it's going to approach this vertical line as x approach -1 from the right-hand side. The very last step, we're going to shift this downward by 3 units to get our f of x defined in this form. The vertical asymptote is at the same location. 0, 0 move downward to 0, -3. It's still going to be a decreasing curve, but this curve is going to pass through this point, 0, -3. And that's the graph of our f of x. Next, we want to determine the domain of our logarithmic function. The condition we have is that the argument of the logarithmic form needs to be positive. This gives us x plus 1 is greater than 0. We solve for this inequality that gives us x greater than -1. Put it in interval notation. We have -1 to infinity, open on both ends. Next, we will look at another logarithmic function defined as log of -x with base 1/2 plus 1. For this one, we will draw the graphs from all those intermediate steps in one picture. Let's start with the parent function, which is y equals log of x with base 1/2. Since the base is less than 1, is a decreasing function. You still have the y-axis being the vertical asymptote, 1, 0 being the x-intercept. It's going down like that, passing through this point. Next, we're going to reflect the graph of the parent function across the y-axis to get the graph of y equals log of -x with base 1/2. This is what it looks like. Y-axis, still the vertical asymptote. 1, 0 will be reflected to -1, 0. Every other point on the graph of the parent function get reflected across this vertical line as well. So this is this increasing curve passing through -1, 0 is going to be the graph of this function. The very last step, we're going to shift the graph of this function upward by 1 unit because we have 1 added to this entire function. The vertical asymptote is still going to be the y-axis. -1, 0 moved up to -1, 1 after the shift. And at every other point gets shifted upward by 1 unit as well. So that's why you have the graph of the final function look like that, still approaching the y-axis as x approaches 0 from the left-hand side. And that's the graph for our g of x. The domain of this function still can be determined by requiring the argument to be positive. The argument is negative x greater than 0. This gives us x less than 0. Put it in interval notation. The domain is -∞ to 0, open on both ends.